our tech lead in the chat. So any doubts that you have in between the like meeting, you can ask in the chat. Sangam should be free to answer them. So if you want to ask anything right now regarding the workshop, just ask. And if nothing else, we shall start without further ado. And also, we do recommend installing VS Code so that you guys can code along with us, but it's fine if you guys haven't, if you guys don't have that. It's today's just basics anyway. So either by today's like today's coding session, which will be taking place from 2:30 to 5:30, you can install it by then, or just by tomorrow, so that you can interact with us for these sessions. Yes, we will be yes, we will be providing the recordings and slides for this workshop. Yes, we'll provide it in the Discord. Okay, so if nothing else, I shall start. The meeting. I mean the presentation. Okay. Okay. Can everybody see my screen? I should probably get this up. Okay, can everyone see my screen? Just type in the chat if so. Okay, okay. All right. So let's start. Okay, so we shall begin with day one. So we are talking about astrocoding. So to begin with, where do you have to code? Like, where do we have to, well, what do we have to use to make our code established and write down programs? So for that, we have IDEs, or integrated development environments. So if you ask me what IDEs are, they are basically like software that helps you with basically everything related to coding. Like if you have some syntax errors, or if you have some logical errors, some documentation problems, or making a virtual environment, IDs help with that. And oh, also I forgot to mention, I'm really sorry about this. Anyone who wants to code along and does not have VS Code can use Google Colab. I've typed it down in the chat. So you can open Google Colab and you can just directly start coding without any extra like installations required. So I do recommend that. Also, someone has joined. Hmm. I'll just keep it. Okay. All right. Let me just share it again. Okay, that should be done. Oh, right. All right. Yeah. So some very well-known IDEs are VS Code, PyCharm, and Google Colab, each of which have their own uh, perks and like cons. But we'll be using VS Code for these sessions because it's a very light app and you don't need like high specs or high spec, like intensive software or hardware for this. So what are the different types of IDEs, right? So first and foremost, we have text editors. So these are very basic ones. Like Notepad can be used as an IDE, but we can't really call it an IDE because it does not satisfy certain conditions. But we can use it to run code. We can be used to write down the text, and we can use a compiler or something to run the code. And on the next level, we have code editors. So these are like proper IDs which which give you extra perks like syntax error correction, or autofilling, and giving you access to the documentation and stuff like that. And VS Code is our example for this this section. So and it is what we will be using. So we have other types of IDs called full IDs. So these have everything and anything you would require to run code, like whether it's running code or debugging, like managing projects, or like integrating it with Git and GitHub. You can have it all. There is no there's like nothing that's left out. So PyCharm is a very good example for those, but these are very intensive software, so we will not be using them for these sessions. But yeah, and VS Code does give a lot of the benefits associated with IDEs, so we will be moving forward with VS Code. Now, notebook environments. So notebook environments are certain special types of mm, files that can help you run cells and see their outputs one by one. We will be looking at this soon enough. In a few slides or so, we'll switch to VS Code, and we can discuss the different types of, well, environments and things that we'll be discussing. So now, these were the things that I mentioned earlier. So what do IDEs do? They make your coding easier. They highlight errors, like if it's incomplete, it will tell you that this is not proper. Like the system does not identify this. It has a built-in debugger. It has an organized workspace for folders, all of which we will be seeing in a bit. It has integrated terminal, extensions, plugins, Git integration, all that good stuff. So now, while choosing an IDE, we usually look at these criteria. So we have experience level. So if you're beginning, VS Code is a very beginner-friendly environment. And if it's a long-term project, PyCharm usually allows you to manage everything better. And for data analysis and scientific work, Jupyter Notebook, which we can also access through VS Code, would be most compatible. So we also have device compatibility. So these full IDs like PyCharm have like a high need for resources. So it can lead to your device going slower, but VS Code is a good alternative because it's very lightweight. So you wouldn't have to worry about that. Basically, VS Code is a very safe option, whether it's a high spec or a low spec code. And if you have a high spec workstation, then you can choose anything. You don't have to worry about the load on your device. So yeah. Now, on to what VS Code actually is. Okay, VS Code stands for Visual Studio Code, and it is an IDE developed by Microsoft for Windows, Linux, macOS, and like all other web browsers. Okay, so We use VS Code because it offers things like syntax highlighting, bracket matching, auto indentation, box selection snippets, and etc. etc. Now, um, yes. Now I'll move on to the actual hub of VS Code. So when you open VS Code, this is how it will look like. This is the main thing. You have different things like new file, open folder, connect to, generate workspace, all that good stuff. So if I just open a new file, just and I can take this chance to show you guys what a Jupyter notebook is. So you guys see this highlighted cell over here, right? So these are the cells that we were talking about in, um, well, Jupyter notebooks. So the pro of this is if we have a piece of code, like say hello world, if I just run this, it will connect to the Python kernel and it will run hello world. So you don't have to worry about, well, error correction or anything, because since we can run this line by line with different pieces of code, it should be fine to, you know, do debugging and stuff like that. So now we have something called the terminal. So this is, if you just take this, actually, let me take a full screen view of this. So over here, we have different options like file, edit, selection, view, go, and run, and terminal. So if we take terminal and we click on new terminal, the shortcut for this is Control Shift and that key that's on your top left. So if we just take it, we'll see that it's basically showing you your path, like which files you're managing. And it's a very good tool for like directly running programs with, such as if I write Python V, now you can directly run your programs within the terminal. Like if I write print hello world over here, you can directly run these commands in your terminal. So you can use the terminal to directly run commands. You can also use them to well, change in file. Suppose, okay, and this is actually another important thing. This is called the file explorer. Wait, I'll just create a new folder to keep my new file in. New folder, and I will select that. Um, should I? So, so a test subject. So yeah. Now that we've saved it, we can see that the Explorer will show us our folder that we have opened. Now we can open a new file within this folder. And if we save it, wait, I'll just open one here. File dot ipynb. That's the extension for, I'll just do this one. That's the extension for a Jupyter notebook. Okay, so yeah. Um, hmm. So when we take the terminal, we have this new NB, right? Now if you will see, the path has updated. Now we are in the a new folder. Now if I have, I hope this works. Yes. Oh, Okay, because that is not a folder, we can't really move into it. But if we had another directory over here, yeah, actually, I'll just add on here. Um, okay, yeah, my bad. So if since we added a new directory over here, if we write cd x new, we will move into that folder and we can work with whatever's in this folder, which is nothing right now because we haven't added anything to that folder. So we'll work with terminal a lot in as we move on, but for now we just need to know that it's useful for directly running programs, navigating files, installing software, which we will be doing a bit later, and automating tasks, basically running code automatically. Now, there is something known as the pip command. So this thing is used for installing certain things called packages into your device. And if you want to if you want to do astrocoding, this is a very important part because this allows us to install packages like matplotlib, which we actively use in the astrocoding profile. So yeah, we open the terminal and we type pip install matplotlib. So this will take a bit, but yeah, because I already have matplotlib in my device, it says that requirement is already satisfied. So that's how you install things. Now about basic Python. So before when we have to get into astrocoding, we need to know the basics, right? Without going into packages or subpackages and everything. This is what Python has to offer without any of those packages. So there are things called data storing entities, which basically hold your data like in a certain with a certain key, so that you can call this data later on, so that you can use the same data like again by just referring to this small piece. So first and foremost, we have variables. Variables are the basic stuff, like you learned that in 6th grade math, like x equals 5 is a variable holding the value 5. And if we update this, if we write another code x equal to 6, the variable will be assigned to 6. So it does not have any fixed value, but we can fix a value for it in a moment in time. So this can be moved later on to 6. The value of 5 will turn to 6. So to show that, I will just print x over here, and I will print x again over here. So if we will just see, it's connecting to the kernel again. Yes. First it shows 5 and then it shows 6 because we have updated the value for x. Okay. Now lists. So lists are a collection or like an array, which is an array is a bit different, but we will get onto that later. So a list is a collection of data. Suppose you have a collection equal to, and these lists are shown by square brackets, 1, comma 2, comma 3. So these lists are something called mutable objects. So if we want to update like any certain ones of any certain number in this, like suppose I want to update 2. So lists have an indexing of 0, 1, 2, and so on. So if we want to call it by the index, we have to put the index number over here, not the actual number itself. So if I write call 0, that's 1 over here, equal to, I don't know, 5, and I print out call, Then we get 523 because now the indexing of 0 has been updated. It has gone from 1 to 5. And similarly, if I change this to 1, it will change to 153. So yes, that's how how lists are mutable. You can change them. You can also do additional commands such as what call dot remove 2. 2 is the index list for 3. So if I print call, oh right. Um, that should be all right. Call P. We'll get onto that later. But if we want to add, we can delete that. Don't get me wrong. But we using the remove command. But we'll move on to that a bit later. But if you want to add anything to the list, like append 6, goal you have 1536. So yeah, with this you can add something to the end of it. And for removing, I think it's hop, hop 2. Okay, we index this to, yeah, 1. Okay, so we have to write the number itself over here. Yeah, wait. Oh, no, wait. By popping it, you remove the last data in the set. So over here, that's 3. So that is removed. But if you click remove 2, yeah, sorry. So yeah, we will be removing the value of 2 from this list. So yeah, those are some basic things you can do with a list. And now I'll show you something called a tuple. A tuple is like a list, but it's immutable. What that means is you cannot change the value of any certain index given in that tuple. So I have a tuple 1, 2, 3. So if I do the same thing that we did with a list, to, oh wait, oh wait, we can't do that because actually this is but we can't do that because we cannot call on this thing to change its value because that is not recognized by the system. So whatever value you have here is what its value will be, but you can assign a different variable to this, like 2, 4, 5, and we can change the variable itself, but we cannot remove anything or modify this tuple by operations. We can add elements to a tuple, like x dot append 1. Oh wait. Uh, mm, oh wait. Oh yeah. Right. We can add things, I believe. Plus 1. Right. Right. My bad. So when I write it just like this, it is not recognized as a tuple. So we have to, and we can only add tuples with other tuples, I believe. I've not gone into much depth with that, but it has to be a tuple. So if we print this out here, print x, we'll see that this tuple has been added to the end of the list. Similarly, you can do this for like any tuple in the like any problem that you can get. So now we'll move on to sets. Now sets are like lists, but they're denoted by curly brackets. So suppose I have 1, 1, 2, 3. A set will only print out the unique values in this collection. So if I have 1, 1, 2, 3, it will only print out 1, 2, 3. So we can do similar operations like x dot append, I believe. Then 5. Oh wait, I'll have to add it again. X plus 5 x. Oh, that's interesting. Hmm. Oh, right. My bad. Oh, my bad. Yeah, we had to make it a set again. Wait, 4, 5. Wait, that is unsupported for a set and set. Oh, we use union. Right. Oh my God. Okay. Actually, we can move on from that for now. I believe it's add, not sure. 4, maybe. Yep, that should work. Wait, what? That did not work. 4, 5. Hmm. The word orange. Hmm. Well, okay, right. Oh my bad. I forgot. Ah, right. Right. Now if we print it out now. Right. There we go. My bad, folks. Small errors with this. So yeah. And since set do not have any like in the like order, we do not have any indexing for this, so it is a bit hard to select certain objects if you wanted to. But yeah, that is a con with sets, but you can preserve distinct values and you can iterate those values, which we'll move on to later. Now, dictionary. Now, dictionaries are certain collection methods that we use for key value pairs. So over here, it is also represented with curly brackets. So we should not uh, confuse this with sets because they have different properties. But these dictionaries preserve key and value pairs. And these value pairs are represented by lists, and each key can be separated by a comma. So just like in an actual dictionary, you have different, like in an actual dictionary, you have different keys to take different sets of data, right? So just like that, for this, we also have similar functions. So what can we do with the dictionary? So we can call upon lists, like we can print out this whole dictionary if we wanted to. See, it will give us the the key and the value, which are the different keys in our a dictionary. Actually, just to avoid confusion, let's just make this key one and key two, key one. So these are the two keys, and they give us these values. So these are stored in key value pairs, and they needn't be distinct. Like suppose if I had 4 over here, we can still store that 4. It's all right to have similar pairs. So yeah, we can also do things like adding a new key value pair. Basically, how we can do that is actually, let's talk about indexing first. So these dictionaries have certain keys that we can call. So these keys can be called upon by typing their name like this. So if we were to print this out, we'll get 1, 2, 3, 4. We can print out key 1. Now, we can do a lot of things with this little statement right here. We can update the values. Now, that is updated. If we print this, see, the values have been updated. That's how we can reassign the values to this. We can also create a completely new key, like a new key value pair by assuming that we have one over here, just like we assigned for the other ones, and we assign it the list that we wanted to hold. So by doing this, we have assigned the list. My bad. Let me just print that out. So by doing that, we print out our key. So key 3. So a new row has been made by doing this indexing. Now there are a few things you can do. I believe we can append to this. Ah, mm, we can. Oh, right. Key. This. Yes. You were saying something, Zatu? Oh, right. My bad. Oh, shit. Right. I had to create the key 3 first. Then. So that should work. Yes. Okay. So what I did wrong was I tried to update a key 3 without defining it first. So since key 3 does not exist in our initial dictionary, we have to first define a key 3 before we can append it with a certain value. We can also do the same thing like removing a value, like suppose 2. So from that, 2 has disappeared because we removed it. So those are some basic operations that we can do on dictionaries. And with this, uh, these are different from sets because they can be called upon, they can be called using the keys, and it's not like sets. The collection is well, not distinct, so we don't have to worry about that. So that's the difference between dictionaries, and actually I'll just keep that. Yep, that's the difference between dictionaries and sets, and a fundamental run through on what dictionaries are. Now we move on to basic operations that we can do in Python. So DMAS, division, multiplication, addition, subtraction, these are basic things that Python does offer without the installation of any packages. So if I do x equal to a, so x equal to 1, and y equal to 6, and I do x plus y. Actually, I just print this out. Print x plus y. So that should print it out. So we get 1 plus 6, that's 7. Same for subtraction. Wait, subtraction. 1 minus 8, that's minus 5. Multiplication with an asterisk. We get 1 into 6, that's 6. And we have division, with which we represent by the backward slash. So we get 0.666. So those are some basic operations, the addition, subtraction, multiplication that we can do with this. And we also have power terms, exponentials. So if you take x as maybe 5, and we do x to the power y, we'll get this number. You can check in your calculator if you want to confirm it, but if you raise 5 to the 6th power, this is what you should be supposedly getting. So yes, those are basic things that we have in this. Now we have iterations. So iterations are basically commands that allow you to repeat instructions for different data types. So suppose I have um, x equal to a list 5, 4, 6, 7. Now I want to I want to go through each and every each and every entity in this list, and I want to do some operation to them. So I can't call all of them at once. So that's why we have something called loops. So we have two types of loops. So we have for loops, which check any ranges and go through and go through the values one by one. And we have while loops, which have a condition like x greater than actually length of x greater than 5. And while loops check for these conditions, while for loops go through each and every single one in this range, and we do an operation to them. So let me show you an example. So for I in x, and we have to put that over there, we have to print print I plus 1. So what we're doing is we are taking any I in X. This I can be 5, 4, 6, 7, any one of those. And we are applying this operation I plus 1 to each of them. So if you see this, it will become 6, 5, 7, 8, which is 5 plus 1, 4 plus 1, 6 plus 1, and 7 plus 1. Now, um, now we check something called for loops. Wait, I'll just return that. Actually, for now, so not for loops, while loops. We'll check while loops. So while length of x is greater than, let's say, 2, we can write x dot pop. Yeah, we can write x dot pop, which will pop out the last right, yeah, the last value. x becomes greater. Okay, wait, no, that is while the length of x is less than 2. Yes, wait, yeah, it is greater than 2. Right. Yeah. So while the length of x is greater than 2, which it is, it's 4 right now, we will keep popping one entity after the other. It will be 7, 6, 5, like that. So if we print out the output that we are getting over here, we'll see that it first pops 7. Actually, let's just make the condition 3 so that we can observe this one by one. So first it pops 6, but and since sorry, it first it pops 7, and since uh, yeah, and since our condition is satisfied, that is x is no longer greater than 3, it will remain at that, and we will have our x. And if we are updating this condition to 2, we'll see that first it pops 7, then it goes on to that second last element, which is 6, and it pops that one. So this condition is done till this condition, as long as this condition is satisfied. And when this condition has been completed, I mean, this condition is no longer true, we update that loop and we break out of it. That's why we went at this, like while length x is greater than 2, pop x. So that is our loop. This little, these two lines, I'll just separate this so that you guys can observe. So these two lines are our loops. So if we so this is where the looping happens, and once this condition has been completed, we move on to our next line of code, which is print x. Okay, I took a bit too much time on that, my bad. It's got present. Not muted or anything, am I? Okay, nothing. Okay. Yeah. So that's basically what loops are. It allows us to, well, do repeated operations to a certain range or with a certain condition. This is an example over here, which we'll have in your PPT. Now we have conditional statements, and these are very important. So let's just take a new piece of code. So conditional statements are basically you check if something is true or not. Suppose x is equal to 10, right? Now we have to check if x greater than 5. Now, if x is greater than 5, we can ask it to print greater than 5. Or we can give it another statement. Wait, I'll just indent this properly. I think I'll have an indentation error over here. So let's see. And as you can see, like that's a useful part of it. There is something called indentation errors. Basically, you have certain spacing that you have to keep if you want the conditional flow to go a certain way. So by keeping it over here, I am not allowing the statement to go further. So that's why we have an indentation error over there. But if I keep it close to this line that we see over here, and I ask it to print x, and then we close it, I believe. Hmm. Oh, right, right. Wait, yes. Okay, so that is our conditional. That's our conditional statement. So if I run this, it will show that obviously x is greater than 5. But that needn't always be true. Suppose if we have x equal to 3, what it does first is first it goes through this condition, checks for this condition. So obviously it's not true since x is lesser than 5. So we check for the condition that x is lesser than 5. Else we print x is lesser than 5. So it goes through the first one, rejects it, and we go to the second option, which is lesser than 5. Now, if you have any intermediate condition, like like in most coding, you do not have this or that. It's not binary. We'll have multiple conditions to like follow, right? So for that, we use the elif condition statement. It stands for else if. So basically, if this isn't true, then we put an other condition instead of just giving a direct else statement. Else, like if x greater than 5, print this. Else, if x, let's say 0 less than x, wait, 3 less than x less than 5. Yeah, and we close that. Yeah. And for this condition, we print, wait, no, we print x is between 3 and 5. Now, if I write 4, so first it checks this condition, else it checks this condition. So we get the result that x is between 3 and 5. So yeah, that's how we check for these conditional statements, and these are very useful because that's how we can show logic flows and stuff in a code. So yeah, useful stuff. Now we move on to a regime in Python programming. So there is something called functional programming. So what we do in this is we have to define a function. A function is any entity that takes in a value, an argument, and spits out a result. So how you define function is you use this def for define, f of x. X is your argument. Argument as in whatever is over here. So yeah, we say if we have an argument x, then we have to print x. Okay, so we have defined here a function. This function takes in a value and spits out something else. So we need to test that, right? So how do we test that? We give an x. Um, mhm, okay. We give an x like 1, 2, 3, and we apply this function for, sorry, not function, that f of x. Wait, actually, I'll just make this to n. So what are you doing here? We are defining a function which is telling us to print out this uh, thing, this n, sorry, that is my mistake. Print out whatever n argument that you're getting. So if I do f of x, it should supposedly print out my argument, that is 1, 2, 3. Now, why is this useful? Because in programming, it will not be just a simple code like this. There'll be multiple lines of code, which we will be doing later. And you can see here that we'll have multiple lines of code over here that does a certain um, that serves a certain purpose. So when you have big codes, you can't afford to write that down every time, because you will want to yeah, you'll have a certain value that you want to apply this to, like y is equal to 2 3 4. So if you write down a big print, like suppose you don't have this defined thing, and you have to write down a big piece of code for this x. Oh, wait. Yeah, suppose you have to write down a big piece of code for this x. So you can't, it's not feasible to write that down in every time, right? So like if you want to do it for another like variable y, then we'll have to write that down again. So to prevent writing that down, we define a function, and we yeah, yeah. We can do multiple things with this. We can make for loops for I in x. Oh, wait. Uh, print I plus 2. So yeah, instead of typing down all this, I can just write f of x and f of y. You get the gist of it. Like this, yeah. So for f of x, we have 1 plus, yeah, 1 plus 2, that's 3, 2 plus 2, that's 4, 4 plus 3 plus 2, that's 5. And for the second one, we have 2 plus 2, that's 4, 3 plus 2, that's 5, and 4 plus 2, that's 6. So these are like the different outputs that we get. And this function helps us to do this for any value that we need this result for. Okay. So yeah, that is functional programming. We make our code into functions, and we eventually use that to um, run similar pieces of code and programming and do whatever we want with it. Now we move on to object-oriented programming. So object-oriented programming is a different regime in Python, in which we do by making things called classes. Now, classes are certain categories which you can build. I'll show you an example, which you can build in Python with, yeah, so that you can build in Python, which have certain attributes. Like within a class, we can give the argument, I mean, say, we can assign functions like this. This is a necessary function called the constructor. And what this does is it gives the object in the class planet some identity, some assigned values. And when it's assigned these values, we can use these values as arguments to assign any functions that are specific to that certain class. Now, this is very important because this is what we will be using a lot, and I mean a lot, in our Astrocoding, because it often involves using packages to assign classes to certain variables like data frames and stuff, which we will come to tomorrow. Uh, but yeah, so let's just try making this whole thing. So I want to make a class called animal. Okay. And I give this some argument. Sorry. Now I have to I have to construct something for animal, like some parameters which animal has to follow to be an animal. So we define in it, oh wait, a self. A self refers to whatever we are applying this class to. Like My apologies. So if we have an animal like a dog, dog has bark. Okay. You know what? I'll just assign dog equal to 1. Right. Oh, it's having that class. I can't intend it either. Right. When that's a problem when you have classes, you can't give those free variables without assigning it something, but you can. Um, right. Like we have not closed this yet, right? So we haven't really defined this function. So we can't move on to other variables without actually defining this first, because we have something over here and that space is empty. So let's just say wait, net. Let's take oh, we have to define the self first and foremost. So we have self uh, over here, and that we have defined a function for self. Let's give it some more arguments like name, um, category, and now we have to define those things. Now self dot name is equal to name, and self dot category is equal to category. As you can see in the slide over here, we assign these values to be these arguments, because it can be some anything else, like self can be I mean name and category can be anything, but we do not know that it's linked to this self. So to link that to the self, we are doing self.name equals name and self.category equals category. Now we can define another function, um, n of x. Now, like here, we can print a function that takes in this value. So if we assign this class to any variable, we can write print animal. So let's try this out. Let's see if this actually works, this whole class thing. We assign a value dog dot animal. Wait, no, I had to define a dog first. Like over here, we write dog equal to like this. We take animal. Since the dog is already assigned, we do not have to use the self parameter, but we have to give it a name and a category. So we give it the name dog, and we give it the category of Canis. Oh wait, my bad. Canis. Right. Yeah. So if I use this function n self on the dog, and now dog, wait, not dog. Wait, have I assigned the class yet? I have assigned it. Now I need to, yes, this, oh, sorry. So when you're using functions from classes, you have to use this dot n. You need to keep this empty thing because you're referencing the self and the self is already implied. So if I just do that, it will print out animal. You can do that for anything. You can add multiple arguments over here. You can put name over there. And instead of printing this, we can just print name. Now, if I just run that function again, oh, we have, oh, right. So since we have added, like if you see, it's given us that it is missing a positional argument, that is name. So what are we missing here? It's an empty one because we know that the self is already implied, but we've added another category over here. We added a name. So what we have to do is we have to put this name over here, and we have to run this function. I believe it should be it. Right. So that should be it. We can also just type in this directly, but well, that's something we have to check. So yes, have I covered most of that? Oh yes. Oh, we missed this one. That's why it's a problem. Okay. So I already told you that the self was already implied. So we now come to why we did this. Like right now, it's a separate argument that we have to put in. But if we have the self, we can use parameters related to the self, like name and category, directly over here. So if we print this, we don't have to add an argument over here. What happens? Since we assigned this class to this, it has done that without having to add any argument, any extra argument over here. So yes, that is the entire point of making classes, so that you can give attributes like Earth, like planet. Now, actually, wait, let's come to that. Now we've defined a class. Now let's make a subclass under this class. Now to make a subclass, it is similar to making a class. You have to construct, not construct. You have to make another class. Let's say, yeah, dog of animal. So this dog belongs to the animal. So we'll just write cancel. Hmm. Right. So I'll just put this dog. I haven't closed it. Oh, wait. Oh, I had to. Yeah. I've defined a new class here, so I can't just do these operations anymore. So we can't just keep this class empty, right? We have to define something under this class. So here our subclass that we are defining is for Earth-like planet. Now, since we already have a constructor planet for this, we don't have to go over the top to make anything else. So what we just do, we define something like a function with the self. Since the self is already implied, wait, no, a function, an x of self, an x of self, and this takes in the argument print self dot category. Now we can directly assign this canis to a certain animal. Now if I'm doing the same thing I did before, I'm taking dog is a canis with the name dog, comma, category canine. I mean, that is obvious, but we are just assigning a value. Actually, let's just say it's a mammal. Like dogs are mammals, so we just give this category will represent as mammals. So canis has been given the properties dog and mammal, and this is the argument which we are taking in the first class. So we have self, we have name, we have category. Self is already implied, so we give it the name and we give it a category. So what have we done? We've given dog and we've given mammal, two separate arguments. Now, I have assigned this subclass animal to, sorry, this subclass of animals, canis, to dog. So if I do any function related to canis, like dog dot nx and close that, then it should supposedly print the category, that is mammal. So you guys might be wondering if it's really that important to actually do all this. And it is. It is for the following reason that most packages, such as pandas or matplotlib, work on the entire property of, well, classes. Suppose um, we haven't moved on to packages yet, but yes, I'll show that to you then. So I hope you guys understand what a class is. It's basically it's basically like a certain collection that it's like a club. It's like a club. So every member in a club will be given certain uh, well roles, right? Like there will be a coordinator, there will be a core member, and there will be a like a normal member. So we can think of like these classes and subclasses like that, because we'll have the club animal, and under the club animal we have like a team canis, which does specific things, which so this canis can do all the things that animal can do, but members in animal cannot do the things that canis can do. So it's like being a representative or a core member with additional responsibilities or properties. So you can think of it like that, and they will have functions of their own which the members in animal cannot use. Now let's move on to the next part of it. I did not go over objects. So whatever inherits the property of these classes is called an objects. They are what we use to express the like attributes given by these classes. So over here, dog is an object. Over here, earth is an object, right? So these objects inherit the properties of these classes, and they are able to do functions from these classes. So yes, that's what objects are. Dog is an object. Yep, that should be it. Now again, I already explained why it is relevant, because our libraries use this a lot, a lot. Let me tell you this before we get into it. I know this looks very simple, and it is to an extent, but when we are coding for packages, all these few lines of code become, well, let's just say a lot, multiple. So yeah, very important. And if we understand the inheritance, we can easily debug as well, because some inheritances might be different from the other. Like some will be inheriting subclasses, some will be inheriting the whole class. So depending on what they inherit, they'll have different functions. And if you know what functions they're inheriting, you can use those functions to do different things for more specific purposes. So yes, that's an introduction into object-oriented programming. Yeah. Now let's move on to a virtual environment. So I understand that I know that I have to, well, do some code, right? So when we are coding, we have, wait, let me just, oh, okay, my apologies. I'll start with global and local environment. So a global environment is basically this: everything that exists without having any cutoffs. Like whatever happens here happens throughout the entire, well, like the entire folder. So what happens is, if you have a certain Python version, and this is very important because yes, so you have sorry, so yeah, you'll have different Python versions which cannot run specific commands per se. So what do you do when you have versions like that? You have to degrade to a lower version where the command works. But if you degrade to a lower version on the global scale, then then what happens is, it the version is updated throughout the scale. So one minute, let me just try some pattern. So yes, it's updated throughout the scale. But if we make a local environment, what that does is it gives you a private space in which you can update your version or packages without it affecting all of the rest, the rest of the packages or versions. So you could have a virtual environment in which you take yeah, you would have a virtual environment in which you take a certain version of Python, like 3.10 maybe, and that will not affect the overall version in your VS Code. So yeah, now this was a bit lopsided. I apologize for the confusion. But now we move on to how we can create this virtual environment. And it's very important, and you will see in later in like the coding problems for maybe day 3, that it is important to make these virtual environments. So let's start with that. Now, so I want, let's just do cd dot because I want to be in the folder while we're doing this. Um, yeah. So let's just do it from scratch. Let's just delete that terminal right there. Now we can go here and click on new terminal. So with this, we have a brand new terminal. And now these code cannot be run on PowerShell because it doesn't have the properties for that. Wait, my God. So I opened something called a command prompt. Now, this is something that can communicate directly and has certain operations that we want out of it right now. So let's type in from here. Hmm, Okay. Um, I will update the slides as it seems there has been some lopsidedness. Yes, I'll update that. Um, but let's just figure this out. First, in PowerShell, you have to create a virtual environment. So how do you do that? You type Python m hyphen m venv my env. So what this does, it creates a virtual environment called my env. There are other ways to do it. There are multiple ways to do this, but this is one of the ways we are telling you right now. So what this does is it creates something called my environment under this folder, new folder, the any folder, new folder. So we created some this my environment. Now, now that we created it, we need to make sure that we are in that environment, right? So what we have to do is we now go to command prompt. Now, what we are doing is we are going to activate the env. So what do? We first take the path of this environment. So as you can see, we are already in the correct path as it's any fold and my environment. So we have something called scripts, and this scripts has something called activate, which we can use to activate this environment. So we are already in any fold. So we go to my environment forward slash, and be careful because this slash is different from the one next to the question mark. Usually it's slashing forward, not slashing backward. So forward slash scripts forward slash activate. Now you can see we have something called my environment over here. So we have activated our private environment. Now everything we do inside this environment will be privatized. It'll be not privatized. It'll be well, private from any outside influence. So why are we doing this? You may ask. That's why I'm getting to packages. So what is a package? A package is a package is like a collection of multiple Python files called modules that are grouped together because they perform similar or related tasks. So packages help organize code in a structured way so that large programs remain clean, easy to navigate, and reusable. So some of the packages that we use are Matplotlib, NumPy, SciPy, which we will talk about. And we use something called sub packages under these packages, which give which give specific properties. And this is why I said that uh, classes and stuff are important, because this is a kind of way to give you specific like things. Like pyplot is a sub package under matplotlib. So when you are taking in pyplot, you get more features than when you just import matplotlib. So we install these packages by taking the terminal, the PowerShell terminal, and we type install um, install matplotlib. So I already have matplotlib, so the requirement is satisfied. But I also have my environment over here. So if I have a file under this environment, let me just take that up. Right now, what we did is we executed this on the global environment. You can see that because in this PowerShell, there's no my env written here. So it was not done in our environment. Now, if we take this command prompt and we take this, we can move into our new file, which, oh, I forgot to create that. Um, right, new file. Now, if we just do this, now if we type out in PowerShell, I will just comment on from this, we'll type out Python m IPy 8 IPy kernel install user name and environment display. Yes. Now, oh, a minute. Oh, right, I did it in the wrong. So PowerShell command. Okay. Oh, okay, wait, it's done. It's done. Never mind. I just saw this. Okay. Now, if we just open an IPYNB file over here, and we make this. Now we have to select a kernel over here because this is under our new environment. So with this, we have installed the notebook kernel and we can select, oh wait, no, another kernel over here. This is the one, yes. Now we have our Jupyter kernel, oh, Python. It should be there. Wait, let's just select kernel, another kernel, Python environments. Okay, finally. Oh my God, that took way too long. I apologize for the confusion. But yes, we finally have the environment kernel. So we are cut off from the rest of the world, basically. Like new folder, like whatever changes happen in new folder and whatever changes happen in my environment are completely separate. And we can run anything over here like I don't know. Actually, let's go to the terminal let's run, wait, not the PowerShell. Wait, let's delete that. Terminal, right? Let's see. This is backward slash my cd. Now, within this, we can install our packages separately. So yeah. So whatever happens here, whatever version you change or anything like that is separate from what happens overall. So you can use that if you have any problems with your package and you can't use it, and change up the environment. Okay. Now this is how you import packages. You type import package name and you assign it with something. So let's say that we are importing Plotlet. Now let's import this as PLT. So it's the same thing that we kind of did with functions, where we are defining all of matplotlib as PLT, so that we don't have to type out matplotlib every time that we have to call on a function from matplotlib. So yeah, so if I wanted to do something like I'll bring in pyplot as well to make our lives easier. So if I wanted to assign something like x123 and y equals 1, 2, 3. Now I'm taking a random function from this matplotlib called plt.plot, and I can plot x versus y. Yeah. Oh my god. Yep. So we download that kernel because we have chosen this private kernel, right, that we are running. So once we have that kernel, we can run this code in that kernel. So we don't have to uh, do anything. Now, sorry about the delays. Just have to wait for this to just install into this. But yeah, well, while we wait for that, I'll I'll just cover the rest of what we'll be doing today. And there isn't much left for today. So basically, we know about global environments. Now we move on to the packages that we use. The kernel is running in the background. Let's not worry about that for now. So some of the packages that we use commonly, especially in Astrocoding, are AstroPy, NumPy, SciPy, Matplotlib, Pandas, and these are more specific um, libraries. But if you're going into astronomy or something like that, then these are extremely useful. AstroQuery, PyCCL, PyCBC, all these are used by astronomers to gather data from these respective bases. So let's talk about the first five main ones, which are the ones that we will be talking about in the next few days. AstroPi. Now, what is AstroPi? It is, oh, something happened with that kernel. Oh, the syntax. Oh my, did I not? Okay, have to install and right, not from. My bad. Hi. Import matplotlib, matplotlib, pyplot as PLD. I'm sorry. I got confused with another command that you can also do. That is from matplotlib import pyplot as PLT. This does the exact same thing that I did. That is, I wrote from over here instead of import. I wrote import matplotlib dot pyplot. So this directly imports pyplot as PLT instead of yeah, well, taking from matplotlib import pyplot, like writing all that down. And now if I run this, what is the problem? Oh, I have not downloaded. Wait, in the environment. So, okay, I need to run it within the environment. So over here, this is the command prompt for my environment. Wait. Oh, okay. Basically, we had activated it here in PowerShell, and we forgot to switch to CMD before taking it. Now, this should supposedly work. Pip install plot lib. Yep. As you can see, we are downloading matplotlib within our environment, our virtual environment. And that, so after this is downloaded, we can use this as a library. Let you wait a bit for that. Hopefully sometime soon. Anyhow, while that loads in the background, we can um, move on to what we were discussing about. So I'll go on to the examples after. I'll go on to the examples after we are done discussing this. So let's start with this. So AstroPi. So what do we use AstroPi for? We use it for units and physical constants. We use it for sky coordinate systems, FITS file, and like managing celestial mechanics and cosmology, calculations of world coordinate system handling, and we also use it to table and catalog data. It's a bit wonky. We'll fix that later. And then we have NumPy. NumPy is a library which uses a lot of mathematical constants, um, such as log or exponent function or sine function. All these functions are not available in Python as such. So we import NumPy so that we can use these functions. And it also has constants like pi or Euler's constant, such as that. Now, we have SciPy. Now, SciPy is what you wish you had in 12th grade. SciPy allows you to run a high-level functions such as integrations and differentiation without actually going through the code one by one. It allows you to do statistical analyses like different tests like I-square tests and stuff. It allows you to do Fourier transforms, fitting functions, like if you have a bunch of data and you want to fit it according to a certain model, like a linear regression or curve fitting, you can do that. And optimization for any given function, we can optimize the function to have a maxima or a minima. So to find out for that, like to find out constants in a function for that, we use SciPy. Now, Matplotlib is what we were just discussing. Matplotlib is a library for the visualization of data, basically graphs. If you have if you had a graph, if you had something, some data that you wanted to graph, such as our data right here. Yes, it's so this is done. So to graph any data and to compare it with other data with similar graphs, you can use Matplotlib. And Matplotlib is very versatile because it goes along with other packages like Pandas and NumPy to give you smooth graphs directly from the other packages. And this is very useful when it comes to testing and experimenting with astrophysical models, because you cannot well, experiment on them directly because, they're far away, I guess. And now for pandas. Pandas or panel data is a package which allows you to tabulate your data in the form of certain structures called data frames, basically tables. These tables will contain information which you can assign according to rows and columns. And you can also read external files which are in different formats like JSON, CSV, Puppet, Feather, all of those formats. And you can import those files into Python and create tables from it. And like I said earlier, this is incorporated well with libraries like Matplotlib and is very useful in our analysis of astronomical data. Now, these are the extra ones that I said. These are libraries that help you access online astronomical data. So any data that is publicly available from JWST, HST, Kepler, these all are telescopes, and other organizations like Vizier, Simbad, Gaia, Archive, NASA, IPAC, all these organizations, their data will be available in AstroQuery. It is AstroPy related, obviously, because, well, astronomy. So you can conjugate it with AstroPy, we conjunct it with AstroPy to make different plots or predictions. Now for PyCCL, that's a core cosmology library. So this is developed by the LSST, NAC and Naxatra Science Collaboration. So this is useful for cosmological purposes. Now, I also want to talk about the difference between astronomy and cosmology, because astronomy deals with has two subcategories, cosmology and astrophysics. And cosmology studies the evolution of the universe as a whole, and astrophysics studies the info from certain objects like black holes or quasars and certain, well, properties of objects, while cosmology talks about things like the cosmic microwave background radiation, the lensing caused by gravitation or correlation between, well, multiple constants in the universe, like a Hubble constant or something. And now for the last one in our series, we have PyCBC. It is a Python library designed for analysis of gravitational waves. So this is developed by the people at LIGO, Virgo, and Kagra, and it's useful for generating gravitational waves, making the waveforms, conditioning the data to fit these gravitational waves, and filtering according to what we require from the data. Now, I am not going into much depth with these five because the entirety of tomorrow will be focused on these five packages and what they have to offer. So I will not be talking much about it. And yeah, also, I don't think we have much time. So there is a channel that I've created in Discord. It's called Doubts. So if you guys have any doubts, you can send it over there. If you have any doubts, you can send it to the Discord. And anything else that have to cover? Any doubts right now? I can do in about 3 minutes. Well, seems to be none. So yeah, let's just do this just so that we don't miss out on this. Let's update this. Yep. Now it's installing. Well, that'll take a while. So yeah, that's it for today's presentation. We'll have um, yes, we'll have a coding session at 2:30, starting from 2:30. So you guys can join then. We will be dividing you guys into certain groups so that we can assign coding instructors to each and every one of you. Yes, we will give you problem statements, and you guys will have to join in as groups, or yeah, you have to join in as groups with which you'll have to do the problems. We'll give you guys the problem statements, and we will have coding assistants to help you with the logic, if any. So yeah, I hope you guys can join us then. So yes, that is it for today's lecture. Thank you guys.